some division stuff today. So this whole chapter is multiplying and dividing with decimals. So we just went through everything for multiplying. So we started actually the very beginning of this chapter with the same type of lesson, except it was with multiplying. So we did estimating products. That was our first lesson in the chapter. And then we started, we did some modeling, and then we learned how to actually multiply the numbers together. We did a decimal with a whole number, and then we did a decimal by a decimal. So now we're going to start the same pattern again, but we're going to be doing division. So the first lesson on division is estimating the quotient. So that means we're going to be using the numbers. We're going to be rounding the numbers or finding friendly numbers that go together. And we're going to find how we can divide those numbers together and get a good estimate when we start learning how to divide. So that way, once we start doing our long division with decimals, we're really going to be much easier. It's going to be much easier for us to find a good estimate to check if our answer is reasonable. That's what a good estimate is for. Okay, so most of the time they want an exact answer, but what we're going to learn today is how to find an estimate so that once you get an exact answer, you can check it and make sure that it's a reasonable answer. Yes.
So we're just gonna estimate and divide it today, or
yep. We're not gonna actually find the exact answer today. Today we're just gonna be estimating. So
I thought we were gonna find the exact answer.
Nope, that'll come tomorrow, starting tomorrow. So today's essential question, the same throughout the whole chapter. So today we're talking about how dividing decimals is similar than dividing when you divide with regular numbers. It's the same steps. Divide, multiply, subtract, bring down. Just like before when we did long division in like I think it was chapter 2 or 3. And so now we're doing long division again, but with decimals. So if you remembered how to do it back then the rest of this chapter should be pretty easy for you. So this is one more tool. Here's your problem of the day. Each day, Kwasi collects 8 rocks and throws away half of them. Oh, okay, so I'm going to think for a second. Each day he collects 8 rocks and throws away half of them. How many days is it going to take him to collect 50 rocks? So if each day he collects 8 and throws away half, then how many days will it take him to collect at least 50 rocks? Now, doesn't mean that there's going to be one day where he collects exactly 50 rocks, but when will it come to the point where he collects 50 or more rocks? Okay, so think about it. Take a moment. I hear lots of different answers for this one. So first we have to figure out how many rocks did he actually collect each day? How many, Aiden? 4 only, because it says he collects 8, but he throws half of them away. So each day he collects 4 rocks. The question is, how many days will it take him to collect 50? So there's 2 ways you could solve this one. You could use multiplication and like a guess and check method. 4 times something, 4 times something, 4 times something until you get 50 or more as your answer. Or you could use division to solve. Some people use division. I saw some people doing 4 divided into 50, and they actually end up with a remainder because it doesn't go in evenly. So if you chose to use division, this is what we get. Then it goes in twice, so it's a remainder of 2. So a remainder means this time that you would have to bump up your answer because since it doesn't fit evenly. The other way, if he collects 4 rocks, now I know that 4 times 10 is 40, right? That's an easy one in my head. So I shouldn't be picking anything under 10 because I know that if he only collects 4 rocks each day, after 10 days he would only have 40 rocks. So I need to collect some more rocks. I have to add some more days in there. So what if I pick 12? What is 12 times 4? 48? Not quite enough. So what did you put? He puts 14. That's 56. What about 13? What happened to 13? Then he collects 52 rocks on the 13th day. That's where that remainder came in too. So the remainder of 2 meant that they were 2 away from collecting the right number of rocks.
If you do that, if you do the remainder 2, just trick. I'm going to call them quick
Okay.
tricks. Quick trick. Add the remainder to the number inside of the, under the bar, and then divide that up. Quick trick.
Oh, you could do that. That would work in this case. You're right. So, correct answer on this one's 13. 13 days. 14 is the correct answer, but it's too many days. It was on which day would he pass 50? So he would pass 50 rocks on day 13. Okay, look over at your notes.
Why does he have to throw away so many rocks he collects?
I do not know. They didn't give us that information.
Why? Because maybe some of them are garbage and some of them are.
There we go. Maybe some of them are not the kind of rocks that he needs. Let's just say that that's what happens, and then we're going to move on to this because we don't have enough time to wait to wonder.
Because he wants to.
All right, here's some notes. We are going to use this word again. Compatible numbers. We also called these friendly numbers back when we did this. We've done a lesson that was actually called Estimate Quotients, except all of the questions were all whole numbers. So we worked with whole numbers and we estimated quotients. Like, for instance, if they said, what is 26 divided by 8? And you were like, I know that 8 can go into 24 about three times. So I'm going to estimate 26 and make it a 24 divided by 8 and say my answer is about 3. Remember when we did that before? And so what we did here was compatible numbers. It was finding numbers that were part of a fact family. So if we know that 8, 3, and 24 are all part of a fact family, and we see an 8 and a 26, then in our head it clicks to that we need to change that 26 to a 24 and get if we want to get an estimated answer. So obviously 3 is not our exact answer, but it's something that's close. You have a question? Or are you just thinking out loud? So we're going to do something like this, but we're going to use decimals today. This is what we did before. Today we're going to use decimals. Let me show you, and then we'll see if you still have a question, since you can't think of what it is. If I have $42.60 divided by 8. So let's say that the word problem says that the person spent a total of $42.60 and they bought 8 cupcakes. Then how much would each cupcake cost? These are expensive cupcakes.
Yeah, they are.
So now let's think about what numbers we can round. So we can either round or estimate. So in your work today, like on your independent practice, some of them ask you to round to get the answers. Sometimes it's going to ask you to find a compatible number. So I'm going to have you do it whichever way makes the most sense to you, because either way would actually be correct. So when you round, what you do is you take the numbers and make it like, this would make this like a 40 and make this number a 10.
Just keep it in 8.
And then you would say, if you were rounding. Now, if you find compatible numbers, you're trying to not change the numbers so much. So really, compatible numbers is a better way where you get a closer to your exact answer.
Leave it in 8.
So if we leave this in 8, basically, here's what I'm trying to say. When you do your work today, you're going to have there's going to be lots of different answers that will all be correct. Okay? We're going to have like a range of answers that will be okay. So one way you can do this, I'm going to show you like several ways. One way is I can make this a 40. Make that $40 divided by 8. So my answer would be about $5. That's one way, right? Because 8 goes into 45 times. Everybody get that? Let's try another way, because I have... Hold on. Let me write... I'm going to write this same question again, but we're going to estimate it differently. So we have $42.60 divided by 8. Here's another way we could solve this problem. This would also be a correct answer. We could change this just to 42. So I've actually just made it, I've just taken the cents off. Then I could make this a 7 because 7 goes into 42. And how much does that equal?
6. 7 into 42 is 6.
So then the cupcakes would be about $6 each.
But I think the
So 5 or 6 would be an acceptable answer for this question. So anytime we're doing estimating, you're always going to have more than one right answer. Like sometimes one answer is going to be a little bit better than the other one. But in this case, either one of these answers would be okay, $5 or $6. Okay, so if you can, try not to change what, basically the number one rule here is that you're going to take the decimals away all the way. Because if you're trying to, basically you want to make sure that you're not trying to change both of the numbers too much, but you are trying to get rid of the decimal because nobody likes to try to divide decimals in their head. So make sure that you try to get rid of that decimal.
So you can round it to the 10 and you can round it to the
Ones, yeah. So if I have 34 and 6/10, here's another example, divided by 5. Think of which way I could divide these or change these and make them compatible numbers. So you can change one or both of the numbers. Make sure you're taking notes. Write down everything I'm writing. What?
You're recording just on the
It's there, it just hides itself. See? Okay, so what's something I could change? Cameron, you got to move now. Nope, go back, go over there, go that way. I know, but I told you that if you talked here anymore, you were going to have to move. So now you've got to move so we can get done with the math lesson. Thank you. So we can make 34 and 6/10. What would you round that to? If I were trying to round it, again, here we go. If I were trying to round it to, you could round it to a couple of different things. What would be the closest number to round it to?
35.
35, because 34 and 6/10. 6/10 is above 5/10, right? Which 5/10 is half. And so since it's above that, it's gonna really, the closest would be 35. Ugh. Something bad's happening here with my pen. Let's try again. Yep. No, it's this little button on the side.
when you go even near it, then
Yes, that's what it is. It's the tiny button on the side of my pen that I try not to touch, but.
if it's if you're not even touching the things, you can still draw.
All right, so that would be the closest estimate. And then my answer would be 7. Because 35 divided by 5 is 7. What if you chose to make it 30 divided by 5? You would get 6. Still another way you could do it, right? 7. Hold on, listen, keep listening. Tristan C., make sure you're taking all the notes that I'm writing. You don't look like you are. Make sure you're writing everything I'm writing. Okay, and then you have to listen the whole time I'm talking. Okay, so this number 7, if you got 7 as your answer, that's going to be closer to the exact answer. So if I actually divided 34 and 6/10 divided by 5, my answer is going to be closer to 7 than it is to 6. All right, let's try this one. We have 2 more examples. So see what you might change these to. If you can, remember, only change one of the 2 numbers. Obviously, you want to definitely change the decimal. And then if you have to, then change the other number too if you need to make it so that you can divide it easily. But if you don't have to change both, then don't change both. So anybody have an idea of what you might change on this one? Hamza, what would you change?
53.2
So 53 and 2/10 could go to 50. And we can leave the 5 alone and we get about 10. What else could you do? What else could you
55?
make it 55 divided by 5 and you'd get 11. So because 53, if you think of a number scale, where 50 is over here and 55 is over here. 53 is actually a little closer to 55, which means our closest estimate would be 55 divided by 5 is 11. Does this, nod your head if this lesson reminds you of the other lesson. Okay, good.
Yeah, it is.
Okay, one more example. One more. It is the same thing. Difference is, hold on. I said one more. This lesson is the same. If you got that when we did estimate quotients before with whole numbers, this one's just almost the same. The difference is you're rounding a decimal instead of a whole number. You're not moving a whole number, you're moving a decimal.
It's also because when we did the multiplications.
Yes, because those are opposites. So if I want to leave the 4 alone, what would I change the 11 and 75 hundredths to, Amelia? 12. And then I would get about 3. Everybody get it? That's what we're doing. Okay, so think of a number line, and where is that number going to fall? 11 and 75 hundredths is like $11.75, closer to $12 than it is to $11. So think of this as this number here is either going to stay the same if this is closer to that whole number, or it's going to bump up by 1 if it's closer to the next whole number. Okay, if you're thinking of a number line. Okay, look over at your math example number 1. So this one's about kites. Miss Glover buys 2 kites.
Wait, so there can't be I have a question.
No remainder because we're estimating.
Also, and none of them there's
No remainder. Every time it should be, so I'm glad you asked that question before I read this example. He said, any remainders? No remainders, because everything should be like something that you can do in your head without having to make, because you get to choose the number. So if you get to choose what you're moving those numbers to, make sure you choose it to be something that's a friendly number that can go into each other. Something that's like a part of a fact family. That's going to make it where you don't get a remainder. So you should have no remainders today. All right, example number 1. Miss Glover buys 2 kites for a total of $15.18. Okay, if each kite costs the same, about how much did each kite cost? So she buys 2 kites. The total for both are $15.18. So we don't need to know the exact answer. It says about how much. Oops, here we go again.
I don't know. I think
Something bad's happening. I don't know why. Okay, there.
Every time you go either go near her thing.
Yeah. I don't know. Maybe something needs to be fixed. All right, so if I change, if I leave the 2 alone, what would I change $15.18 to? $16. You'd bump that up. Because if you leave it as 15, you can't, it doesn't go in evenly, right? And then, or you could put it down to 14, but it's not going to be as close of an answer, because down to 14 would be $1.18 less. But if you bump it up to $16, then it's only going to be like 84 cents more. See the difference? So it's going to be a little bit, the estimate will just be a little bit off from the actual answer. You could do 14. So if you divide 16 by 2, you would get 8. So each kite cost about $8. Not exactly $8, actually a little less than $8, right? Because if each kite cost 8, the total would be 16, and the total's a little bit less. So this little part right here, this little helpful hint, bless you. That's something good to remember. Compatible numbers are numbers that easily can compute mentally. So you may have a hard time if you don't remember your basic facts very well. If your basic facts are hard for you, you need to make sure you're studying them, because then those fact families won't stand out quite as much as they should if you're not sure about your facts. So study, study, study. All right, so since 2 times 8 is 16, and 16 is close to $15.18, your answer is reasonable. That's how you check if your answer is reasonable. Example number 2. 3 friends went out to dinner. The total cost of their meals was $32.57. If the friends split the bill evenly, about how much will each person pay? Explain why your answer is reasonable. So if we're going to estimate $32.57 and we're going to divide that by 3, we could round $32.57 to the nearest whole dollar because 33 and 3 are compatible, right? Because we know 3 goes into 33. So if we make 3257 up to 33, we leave the 3 alone, what do we get? What do we get, Nolan?
11.
11. So each friend will pay about $11, since 3 times 11 is equal to 33, and 33 is pretty close to the original amount of $32.57. Your answer is reasonable. That's how you check for reasonability on your answers, because it does ask you that. It asks check for reasonableness. So when you're doing that, the way you do it is you make sure that your answer, like this, is close to this. That when you do, if you do the multiplication instead of the division, that those two numbers are still close to each other. I'm glad that this one doesn't seem too bad because we've done this before, so that is helpful. All right, so on the guided practice, I want you to work those 3 out, check them with a neighbor, then you can start your independent practice today. You've got until 1:30. That's your 20 minutes.